So today we're going to start looking at statistics, but before we look at it, we really need to stop and make sure we understand what exactly it is that we're talking about. Statistics means the process of collecting, organizing, and interpreting data. Now, there's lots of ways we can collect data. Some common ways are using surveys, frequency tables, things like that. And we generally organize our data with graphs, charts. We can use spreadsheets, things like that. And then when we interpret it, it means we're somehow utilizing that data to make conclusions, to make some decisions, things like that. So for example, we could collect data about, we could use a survey to collect data about what genre of books students like to read. And then we might organize that by putting it into a spreadsheet and using that to make a bar graph about the genres of books that students like to read. And once it was organized like that, it would be easy to interpret and make decisions about what kind of books to buy for a classroom library, or maybe what kinds of genres to use for read aloud or something like that. So statistics is basically when we collect, analyze, and use our data to do something. And before we really can start collecting, we need to make sure we understand what a statistical type of question is. So thinking about a statistical questions, the biggest thing is they have to be able to have a variety of answers. And usually it helps if they name a specific population or group. For example, if I simply asked, how old are you? That is not a statistical question because there's only one answer. Right now you might be 12. Well, great, that's the answer to the question, but it's not statistical because there's no variety in that. If, however, I asked, how old are the students at my school, then I could survey lots of kids at my school, and presumably they're probably going to be a variety of ages, and even if they're not, there is the possibility that there could be a variety of ages. And also, I've actually named a specific population, which once I collect my data and I wanted to present it, it does specifically tell what group it is that I'm talking about as well. So let's look at some examples of questions and see if we can figure out whether they are statistical questions or not. So take a look at each of these, read them, and decide whether or not you think they are statistical questions. Remember, a statistical question must be a question which allows that there could be some variety in the answers. If there's only one possible answer, it is not statistical. So take a minute, read each of these, decide what you think, and then check your work. All right, now that you've had a chance to read them, these are what you should have put as your answers. And the ones that are not statistical, for example, how many states are in the U.S.? There's only one answer to that. How far did Terrence drive to work today? How old is Sarah's dog? How many inches are in a foot? All of those have only one answer. When we look at our others, what is the favorite song of 13-year-old girls? Well, you'd have to survey a bunch of 13-year-old girls, and they're probably not going to all have the same favorite songs. But even if they did, there's still the possibility that there could be a variety of answers. So that is a statistical question. The same is true of my classmates' height, the shoe sizes of 12-year-old boys, and the cost of feeding a family of 4 for a week. And then the last one, how much time do teens exercise in a day? All of those are questions where you could survey people, find out their answers. There's likely to be some variety in the answers, and then you could choose a type of graph to show that information. So those are the kinds of questions that we're talking about when we're talking about a statistical question. Now let's go into some ways that, given numerical data, that we could organize and summarize that numerical data. And we could do that using statistical measures. When we're going to use statistical measures, the first thing that's really helpful to do, it's not a rule necessarily, but the first thing that's really helpful to do is to put all of the numbers in order, because that's going to make it easier than to analyze your data. When you want to find the mean of a set of numbers, that is the average. We're going to add all the numbers together, and then we're going to divide by how many numbers were in the set. The median is the middle number in a set of data. And that should make sense because we should know that the median in the highway is the grassy strip that runs between the two lanes. So to find the median, we're going to find the middle number. If there's two middle numbers, then basically we're going to average them. We're going to add them and divide by 2. The mode is the number which occurs the most often in a set of data. And there can be more than one mode. There might be no mode in a set of data. If no piece of data is repeated within the set, then there's no mode. If some of them are tied, let's say there are two pieces of data that each appear 3 times, and that's the most, then both of those are the mode of the data, and that's okay. The range of the data is when we find the difference between the largest number and the smallest number. And then the outlier, an outlier is not a measure of data necessarily, but it's something to be aware of, that when you have an outlier, that's kind of an oddball. It's a piece of information that doesn't really fit. It's a piece of data that is either much larger or much smaller than the other data in a set. And because it's there, sometimes it can impact some of our other statistical measures. So let's look at an example. Let's look at a student's grades and do a statistical analysis of that student's grades. So student number 1, these are their grades, and you're going to want to start, like I said, by writing them in order from least to greatest. It might be helpful as you go to cross out the numbers you've used. That way when you're done, you can make sure that you've used all of your numbers, that you haven't left anything out. So I'm going least to greatest. I'm going to write 83. And then 85, 85, 87, 95, and 99. To find the mean, I need to add all of those numbers together, and then I'm going to divide by 1, 2, 3, 4, 5, 6. And so when we do that, when we add all of those numbers together, we're going to get 534. And again, there are 6 pieces of data, so I'm going to divide by 6. And when I divide by 6, I'm going to get 89. Now, let's talk about that process for just a minute, what it is that you're doing actually when you find the mean. Let's look at it with some simpler numbers. Let's say that we have 4 people who all have a different number of counters, and we want to average those. Now, we could go through the process of adding them all together, dividing by 4, because there's 4 people. But what you're really doing when you're doing average, really what you're doing is sharing equally. So what I mean by that is, right now, if I look at this, I can look at this and say, well, here I see everybody has at least 1, at least 2, at least 3. But now look up here, Amber doesn't have a 4th one and everybody else does. So I have to give her another one so that everybody so far has at least 4. Sarah and Haley both have 5, but Megan and Amber do not. So I need to redistribute some of these that Sarah and Haley have, start making this more equal. Okay? Now, I'm going to go up one more time and notice once I even this out completely, everybody has 5. So the mean there was 5. Even though my numbers didn't start out with everybody having 5, if I share equally, that's how many everybody, or having 6 rather. If I shared equally, everybody would have 6. So that's what you're basically doing. When we started out, there were 24 total, but they all had different numbers. When we even it out so that everybody has the same number, that's basically what you're doing when you're finding a mean. So when we go back to the student number 1, we could have done the same thing there. We could have started out with our higher numbers, 95 and 99, and taken some away from those to give to the lower numbers until we had everything balanced out. And if we did, then everything would balance out to all 6 grades being an 89. That's what a mean is. So let's talk about median next. Median is the middle number in a set of data. So when you look at a set of data, basically you're going to say, well, it's not this one or this one, so it's not the 83 or the 99. They're the two biggest and smallest. They're the biggest and the smallest. It's not 85 and 95 because they're the next largest and next smallest. And then I'm only left with 2 numbers in the middle. If I cross both of those out, I have nothing left in the middle. So I have to look at those 2 together. And I'm going to find the mean of those 2 numbers. So that means add together 85 plus 87, which is 172. I'm going to divide that by 2, because that was 2 numbers, and I'm going to get 86. That actually should make perfect sense, because what's exactly in the middle of 85 and 87? That's right, 86. Our next statistical measure is mode. Mode just tells which number occurs the most. So this student got more grades that were 85s than anything else. The student had 2 grades of an 85. All of the others were something different. And then looking at the range of this student's grades, the range is from 83 to 99. So when I subtract 99 minus 83, I'm going to get 16. So what that tells me is that all 6 of those grades were within 16 points of each other. Now let's look at another student's grades. This is student number 2, and I'm going to put student number 2's grades in order. Again, it helps to mark out as you go. 0, 87, 87, 89, 93, 93, and 97. So I'm going to add all these grades together to find the mean. When I add them all together, I get 546. And to find the mean, I need to divide by 7 because there were 7 grades. When I find that mean, the mean is going to be 78. The median, this time I have exactly one number in the middle. The number that's in the middle is the 89 because if I look at it, there's 1, 2, 3 numbers lower than 89 and 1, 2, 3 numbers higher than 89. So the 89 is in the exact middle. So our median here is 89. Our mode, we actually have 2 modes, 87 and 93, because both of those occur twice. The range of our grades is 97 because the largest number is 97, the smallest is 0. 97 minus 0 is 97. So that means this student's grades have a much larger range because they range from 0 to 97. There is a 97-point difference between the smallest and largest grades. Now, this is important because when you look at this, which student would you say is actually performing better? Well, there's a couple ways you could look at that. The quick way to look at it, and the way people often look at it, is to look at the mean because that's how grades are generally reported on a report card. And student number 1 has a higher mean. Student number 1 has a mean of 89 and student number 2 has a mean of 78. That's a pretty big difference. However, if you actually look at their grades, student number 2 has 6 out of 7 grades are 87 or higher. Student number 1, only 3 out of 6 grades are 87 or higher. So you might look at it and say, well, yeah, student number 2 has the lower mean, but really, student number 2 probably understands the material better than student number 1, rather, because they had almost all of their grades were 87 or higher. What killed their mean was the 0 that they got on one assignment. So the lesson in that is looking at when you have an outlier, which for student number 2, the 0 is an outlier. It's very far away from the other grades. When you have an outlier, that's going to significantly impact your mean. It's also, if you notice, going to significantly impact the range. Look how huge the range is for student number 2. If we did not include the outlier of 0, then the range there would be 10 points. All of those grades are within 10 points of each other. So it's really important when you have an outlier that you look at your median, you look at your, in addition to looking at your mean, so you can get a clearer picture really of what's happening there. And it's also important to look at your range because if you have a large range, that tells you something about your data as well. Speaking of which, we also need to know the terms measure of center and measure of variability. A measure of variability is a measure of how far the data is spread apart. So it's one number that describes how much the data varies, or in other words, how far apart it is. So looking back at our statistical measurements, range is the one that tells how far spread apart those grades were. So range is certainly a measurement of variability. If the range is very small, that tells you that your scores are close together. If there's a large range, it tells you that they're more spread out. Now, it doesn't necessarily tell you if they're evenly spread out or if there's one that's an outlier, but it does tell you that it's more spread out overall. And then measures of center, they're one number that summarizes the whole set by giving a number that is typical of the set of data. And generally, we would say that the median, which is truly the middle measure of center, that makes sense that median then is going to be a measure of center. The median is one of our measures of center, and the mean actually is also a measure of center as well. It gives a grade or a number that would be typical of the set. The mode isn't really a measure of center or a measure of variability necessarily, but the mean and the median are both measures of center. The range is a measure of variability.